Good morning, everyone. I hope everyone is doing okay and thanks for joining. We will be starting in a minute. So let's give others a bit of time to join and we will get started. Just one more minute and we will get started. Thank you. Just let us know how was your last week, what you did, anything related to technology, anything interesting, anything which you want to share. Please feel free and let's leverage this time for everyone to get joined and we will then talk about interesting stuff. So let me know what you did last week. Anything interesting to share? I'll give my details. I'm working on creating a ebook for this service summary card. So I started compiling it. I need to get through some approvals internally before I publish it. So I'm halfway through it. And probably I will be sharing that book details in the coming BeSA session. I'll keep it free for BeSA people and then we'll see how it goes. So that is for certification exams. All right, work extensively on IAM, Rahul. Nice. IAM is always there. IAM is never going to be away from it. Terraform, Sentinel, AWS POC for larger community. I like that Debashish sharing with community is always interesting. Basically, you also enrich yourself once you start sharing. So you would be amazed like how much you can learn from sharing with other people. So let me welcome my wonderful colleagues here. I'm adding James, I'm adding Prasad, and I'm
I'm adding
adding Crystal.
James. I'm adding Prasad, and I'm adding James. I'm adding Prasad, and I'm adding
Anyone?
James. I'm adding Prasad, and I'm adding
Anyone?
James. Adding Prasad, and I'm adding James. Adding
Sorry, there was some echo. Not sure how it is coming up, but yeah, I have added both those people, and let's get started. Yeah, a lot of echo was there. Sorry for that. Maybe somebody forgot to mute their mic, but it's fine. Let's get started, and we will get started and discuss about what today we are going to talk about. So I'll quickly talk about what options are. We will quickly go ahead and discuss interesting stuff here. Let's go ahead and start. So we will talk about things related to microservices, an interesting topic, and you would realize that microservices has lots and lots of components inside it. So I'll quickly talk about what microservices are and how it functions, what things we need to take into account. So what are microservices and serverless? That's what I'm going to discuss. Then I'm Uh, then I'm going to talk about microservices, the hard part. Sorry, that would be James. James would talk about got the good, bad, and ugly about microservices because it looks like it can solve everything, but there are some challenges you have to address. So we'll discuss that. And then Prasad would walk us through the question he asked in the last sessions, talking about, hey, what you would do, how you would create, select a database for your startup. So we'll discuss those components also as we move forward. So let's get started here and we will discuss about what microservices are and how it actually works. Now, to talk more on the microservice part, I want to talk a little bit on how our application has evolved over a period of time, because then it would give you idea that, hey, it's not like one time thing we came up to microservices. There are a lot of things which happened before. So let's get started with understanding it. Now, I have put some timeline. These are not exact timeline, but it is just to give you some idea that how we have actually evolved and come up to cloud or come up to microservices. So let's get started with that. So in early days, if you worked that early into software development was basically a waterfall type of model. Like there would be stage one, which will be requirement gathering, then analysis, and then coding and deployment, and then execution. And that was a one after the other. So the product would become ready after a very long time, and you could not go up. Waterfall always come down, right? Water cannot go up. Similarly, once a product or software is into development, once requirement phase finishes, then it goes to analytics and then so on, and you could not change it. So that was a waterfall model. It worked well, but it has some shortcomings, so they had to change that. Now, while this was happening, the application architectures we were using is basically a monolith architecture. What is monolith? I'll talk about it, so don't worry. But monolith is a way to deliver your component in a way like it's a one single indivisible application. Then the packaging or how we used to deploy these services. You would take one physical server, have your operating system installed on that, have any binaries you need for your application, and then let the server run. That's how you used to deploy. And then Mostly companies were utilizing data centers. So data center would be where your applications would be running. So this was an old approach, still exists in lots of places, but yes, this is how we started with doing with computing and services and application. Things changed a little bit in 2000, 2010. What we started seeing a lot of momentum for agile. Agile ensured that we do not have to wait a long period to get a product and then realize there was a problem. So we have shorter sprint cycles, and those cycles would help us to be on track, invent, and then correct the mistake first, very, very fast, not waiting for a long period of time. So this agile methodology came in, and when this agile came in, then people started talking about N-tier architecture. N-tier architecture basically is like, hey, let me have a front end, then maybe have a middle tier, then maybe a back end. So three-tier architecture, two-tier architecture, they have become very common. That's what we sometimes call N-tier architecture. And till this time, virtualization was in full swing. So instead of having one physical server dedicated to one single customer or application, what customers started doing, they started having lot of component put together onto a virtual server, and that's how your web server become very common. So that's how your virtual server has evolved. Until this point, customers also realize that we don't want to run this data center for long period. And then companies like OVH Cloud, then companies like Rackspace, they started coming up, and customers started hosting their application in their data center. This approach is what we call a hosted approach for running your application. So this is how our application has evolved, right? Obviously, we don't stop there. We still have to keep on evolving, and that is where the development process which has come around right now, or what is very popular nowadays, is what we call DevOps approach. So DevOps approach is basically ensuring that we both are working together as a development team and operation team, and we are working toward building the solution. So then the approach came is a DevOps. Then in terms of application architecture, this is where microservices fit in. Now we started breaking down our application into start from very big bulky application to smaller services like microservices, and they are talking to each other through well-defined API. There are some ways they are connecting to each other. There may be some persistent layer between them for data storage. So that's how the architecture has evolved. And then till this time when this microservices has become smaller and we do not need the full power of a virtual machine, then we started seeing containerization becoming mainstream, and Docker, and then then your Rocket. These all platforms came in and they started containerizing the workload. So this is how your containers has come into the picture. And till this point, we have realized that cloud is the best way to deploy services in a longer run. So we moved to that point, and now we have this whole cycle. So what we will be discussing today, we will be talking about microservices, how it works, and in cloud, I would talk specifically about how uh, your serverless architecture work, but this is how the timeline looks like, right? So hopefully everyone is clear. It's not like an overnight thing. It happened gradually, and it's not like only one place change happened. You could see containerization, DevOps approach, cloud, and microservice. That has become the new normal for software development and deployment. So we'll be discussing more on that. Keep your questions coming. We'll be happy to answer them as we are getting these questions. And even after this, if you have question, just feel free to reach out. We would be happy to answer any questions we have. Okay, good. Now, let's talk about monolith versus microservices. Let's see how the differentiation is and how we are going to utilize it. Uh, right. Right. Let's move forward and talk about monolith and microservice. And as for me, like I can't discuss anything without giving a analogy. So let me give you a very small analogy to bring home the point of microservice versus monolith, and then I'll go into the technical details about it. Right. What we have here, a taco stand. A taco stand, a food stall, is one single person operated. That single person is taking care of everything: customer satisfaction, manufacturing, marketing, raw material, hygiene, then sales, then accounting. That person is taking care of everything. That's what a monolith is. Let's take this example and say, let's say we have graduated to a bigger pizza place. This is how a pizza place may look like. Now you could see there are multiple people involved. There would be a baker who would only be doing the baking stuff. He would be creating the pizza, baking, putting it into oven, getting it ready. Another person may be doing packaging. So that person is involved only on getting the pizza from oven and then packaging it to go to a destination. And if it is like a in-house dining, then probably there would be a server who would be sending or giving this pizza to the customers who are waiting on the table. So that's how what we did here. We are still serving food, but now the work has been divided. What we are seeing here that the person who is baking pizza is completely different. He may never know that who actually ordered it. Someone who is packaging the pizza who would never know that how much ingredients were used by the baker inside it, and somebody who is serving the pizza may never know whether it was paid by cash or whether it was paid by card. So actually what is happening here, we are dividing things and ensuring that everyone works as a single unit, but still everyone is doing their own part, right? Hope everyone is okay so far. Let's move to the little more sophisticated way of working. Let's say instead of a pizza place, we now go to a fine dine restaurant. When you go to fine dine restaurant, it would be little differently approached there, right? You would be greeted by someone in the very early. Let's say you are coming in and you would be greeted by a person. He or she would take you to a desk, ask how many people you have, like where you want to sit, a quiet place, or you are okay to sit into a crowded place, whatever the preferences is. So that person would take you to a table. Now, once you are there, afterward, what you would be having in that you would be able to see there would be multiple people. There may be a bartender, maybe there would be a person who is ensuring that you get your welcome drinks on time. There may be another person who would ensure that you get your snacks on time or you get your food served on time. So that is the different persons getting involved. Maybe bartender, maybe a server, maybe another server who is coming in. And at the back end, there is a team of chefs who are working to ensure that you get the food you ordered. Now, if I'm a chef inside the kitchen, I would never know that who actually has utilized or who actually ordered what. For me, it would be just a table number. My order would come to me as a chef and it will say, hey, table number 5 ordered XYZ, prepare XYZ, and then give it back. Simple, right? So that's how your all the work is being divided, still working as a single unit, but you are all divided and utilizing all your stuff. So yes, pizzas can help you a lot. Pizzas, if you know about pizzas, a lot of things in cloud are very simple, isn't it? Thank you, QWS. Okay, so idea here is everyone is talking to each other, but in a different way. Let me give some examples so that you could relate to how the things are working here. Now, when somebody is coming to your table to take order, they would write down that order maybe into a tablet, maybe into a notepad, and that notepad or note would be then served to the chef into the kitchen, and there also would be a master chef who would take care of who is going to prepare what. So if an order contains a soup, it contains a main course, it contains a side, maybe there are different chefs inside who would take care of it. So somebody would read that information what is being requested and then divide that information into different tasks and deliver it to the backend. So that's two things we are seeing here. There is a front end, there is a back end, and we do not have to worry about back end. We go to restaurant, we expect that we would be given a menu, and once we get that menu, we can go ahead and order the stuff, and based on that, we would be able to get our stuff. And we would ensure that if we are ordering something, we get the correct order. How they take care of ordering things correctly, from where they source their ingredient, I have no idea on that. And actually, as a consumer of the services, I should never be worried about it because that is all their internal stuff and they can take care of all the stuff for them. So that's how your restaurant business may be working, right? And don't worry, I was not in restaurant business, but I like how they operate efficiently, especially the fine dine restaurant. They do things very perfectionally. So that's why I'm just taking some examples there. All right. All right. Good. Now, what else? So this is just keep at back of your mind that this is what a difference between microservice and monolith may be. But now let me go to a technical context and try to understand what your microservices are or what your monolith are. So let's first talk about monolith. Can you share use case for when to use ECS or EKS? That would come, but it's not today's session. Probably we can discuss it little later. You can send me some messages, and I would be happy to respond it on the chat, on the LinkedIn if required, but not today. Sorry, we can include container in some other section. Okay, so talking about what a monolith application is. Monolith is basically it is a one large system, and it is usually one code base. From very beginning, somebody started and thought, hey, this application which we want to build should be built into Java. So what we should do in that case, we should take the code base as Java and start deploying code inside it, start developing the stuff and make it like one single unit. That is what is built as a single and indivisible unit. It is everything is put together into one single unit. They are designed without modularity. There would be one code base. You would keep on checking in your code inside. You would keep on compiling the code or maybe interpreting the code, and then you would get your application, and those whole component will be deployed at once. Now, there would still be logical bifurcations that there would be a user interface. There would be some business logic who is processing the information, and there would be some data access layer who would be storing the data which you are using or storing, and that data would be probably going into a single database, and everyone has to follow from user interface to business logic. Business logic will talk to database layer, and then data access layer can talk to database. This is what a monolith application actually looks like. And all these components depend on each other for work. If any of them is not working as expected or any of them is not functioning as expected, then you won't get the output coming in, and all of them are leveraging one single source of your databases here. That's what a monolith approach is. Now, we are not trying to say that monoliths are bad. We are just saying monolith is one approach, but in some scenario it may not work. Like if I give you an example, in very early days when Amazon.com started, I'm talking about Amazon.com, not AWS. Amazon.com was initially a monolith which was on Java, and the backend database we had was Oracle, right? And we were scaling this Java application multiple times. We were making sure the database is operating as expected, but obviously it was not very efficient for long term as the business was growing. This approach was not able to serve the purpose. We were not having that type of thing. In very early days, when we started utilizing this approach, we had a 3 month release cycle. Every 3 months there would be a code base change happening, there would be new functionality added into Amazon.com. But if I'm talking about today every 90 second or even less than 90 second there is a code change happening in Amazon.com without any downtime, without any problems, and that's how we are rolling out new feature to customer faster. And that was not possible into Monolith, because here what is happening, there a deployment happens all at once. You could not deploy them in shorter period, and then component depend on each other for work. Now today if you go to Amazon.com homepage, that Amazon.com probably is made up of 200 plus microservices. Maybe one microservice for your product of the day, another for your account, another for the last order you process, another for your browsing history, another for recommendation, n number of things. And that has become like a microservice driven architecture. And I'll send you some links where you could get more idea on that, how actually Amazon.com evolved. So that's what Monolith is. Now, what are the challenges in this particular approach? Let's try to understand it. So, monolith challenges, they are barrier to adopting new technology. Somebody start in very beginning that, hey, we are going to use Java for it, or we are going to build this application in PHP. Maybe now we have a better language, or maybe we have a better front end, but we can't change it because it has been there from long time. So it is a barrier to adopting new technology. You cannot make certain changes there. Continuous deployment is difficult. If you're deploying again and again, then every component has to sync in. What about there are 4 teams working on it? 3 teams are ready with their code, but one team is still not finished. They are still waiting for the code. which means you still can't go with deployment because they are all dependent on each other. And over a period of time, your code base become larger and complex. It would be complicated to maintain it. Microservices may be difficult to scale also, because what happens if it is my monolith, sorry, monolith are difficult to scale, because in monolith, I have provided some CPU or RAM or processing power to this. Now, what if I'm running a campaign and I need more processing power only for business logic? Probably it won't be happening, because when I'm adding CPU or RAM, that is happening for the whole monolith application. So that can be a little challenging to scale them, and obviously it will become difficult to maintain. There have been too much changes happening, and that's why you may find it little difficult to manage it. So that's why some monolith challenges are, right? Okay, what happens now? Let's go ahead and talk about how our architectures actually work. Let's see what microservices are. So we'll talk a little bit more on the actual understanding of microservices. So let me talk about what microservices are now. So applications which are composed of independent services that communicate over well-defined API. That is the most important aspect of a microservice. There should be a well-defined API. API is basically an interface, which we expect to be same for whatever way we communicate to it, right? So if I am answering a phone, then there is a method I am following. Whenever I answer a phone, I say hello, or I ask who are you or why you are calling, kind of stuff. So that interface kind of will remain same. I'll give you some more example on the interface side of API, but API is basically an interface by which you communicate to someone else. We will discuss how interfaces work. So what you are seeing here, that my monolith application or architecture is having all these components, your user interfaces, business logic talking to each other and having one database. But if I'm looking at microservice architecture on the right side, things are looking differently here. What I'm seeing, that there is a central place which is a user interface. Now, this says it is a customer facing application, but it may happen that this application may not be customer facing, so user interface may be missing. What happens now, that through this, all these independent services are talking to each other. And another aspect which you could be very important to understand here is that these databases are different. We call it purpose built databases. We don't want to keep data into one single format databases. It may not work well for all of it. It may not be well suited for all type of workload, and we may want to keep this data into different architecture, different databases. Sometime I would prefer to have a NoSQL database. Sometime I may prefer to have a graph database. So it depends. But idea is that every microservice is then ensuring that we are keeping their data into a database. This is what we call purpose built database. They are using a very specific database for a very specific cause, right? So that's how your microservices would work. Now, when I say database, it doesn't always have to be have database. What I prefer to call it that there is some persistence layer. What is a persistence layer? Something where I would be keeping some data, and that could be maybe a queue, that may be a database, that may be a S3 bucket, it could be anything. But what we are trying to avoid, that we don't want these two services to talk directly in the sense they should not be depending on each other. In between them there should be some mechanism to hold data. So service A wants to talk to B, it will push data here, and B would pull data from this queue or storage and get started. Like in your example of a restaurant, when a waiter has taken your order, it won't wait for the chef to listen to the whole order. He would have written it onto a page or onto electronic system, and this would be transferred to the chef. So that's how chef would know what needs to be prepared. That's exactly what we are trying to do. We have stored our data, we persisted the data somewhere. If this page is not there, then this waiter has to wait for chef to be available and explain everything, which is not at all a good design. And we are ensuring that they communicate, but they make sure it could be a different. Devasis's question is, the persistent layer can be SQS Kafka. I would say it could be anything. It could be anything. It could be a caching service. It could be a SQS queue. It could be Kafka stream. It all depends on what kind of architecture you are building up. So if it is a real-time architecture, probably Kafka or Kinesis would work best in that case. But if this is a asynchronous architecture, maybe SQS, maybe S3, it could be anything. So it doesn't need to be a specific database or a service, anything which could hold data for a while till somebody else picks up. And that's what you could use as a persistent layer. So it should not be a problem at all. All right. Hopefully everyone is following along and understanding the concepts related to microservices. Now, is microservice going to solve every problem in your environment? I would say probably not. We would need to think whether a microservice is required or not. And I don't expect that from very first beginning, let's say you are starting a project today, that from very first day you would start doing microservice architecture. If you're doing it, probably you will hit a lot of roadblocks. So what we want in this particular case, we want to have a different approach, and this is well documented into a nice article, and I would highly recommend you read that. That is coming from James Fowler, sorry, Martin Fowler, and this is the reference. I will put that into the resources page, and that talks about monolith first approach. Idea is going directly to microservice architecture is risky. Yes, we want to build a microservice architecture, but start with a monolith. Try to see that what component have dependencies, what can be broken down into smaller pieces. So you start bigger first and then start drilling down that, okay, one component can be made separate, complexity rises, start breaking out some of the microservices. So that is how the approach should be. I don't see expect people to directly go to microservice architecture. Maybe at least they would start with this and then realize that, hey, this one is going to be a bottleneck and we have to fix that problem, and then we may want to start that breaking down process for our application. And we have a lot of tools available, services available, in which you can do that through a no downtime approach. And I'll send you some more links today if you want to follow this approach, that you had a monolith application and then you break it down into smaller micro services and still do not have any downtime at all. So those all options are available. So hopefully everyone has little more idea on how it actually works. So it's a nice article called Monolith First, and it talks about like what can be challenges and what kind of things you should be taking into consideration. Okay, what else? Now, microservices would have a very specific thing. What is the specific thing we are talking about? So first thing we would have is a polyglot persistence. Now this is like a UI issue here. What is polyglot? Polyglot says that we want to have an architecture in which we are not dependent on a specific technology. So what we are looking for here is a polyglot persistent. Let's say my application requires these four components to work. They would talk to this and this. Maybe just give me an example. If I feel that first component is better suited into Java, second would work best into PHP, third will work best into .NET, and fourth will work best into Node.js, no problem at all. So we can go ahead and say, hey, it is a polyglot persistence. And then polyglot persistence and polyglot framework means you may use any type of databases as a persistent layer and any type of languages to get your work done. So that is what we mean by a polyglot persistence. So polyglot persistence is something you should be taking into consideration when you are building microservices. Microservices are decentralized. We are not trying to put everything into a central place. We are trying to decentralize this as much as we can. And then what else? We are trying to go ahead and have a polyglot persistence. We are then doing what? Do one thing well. When a microservice is there, it would be doing one thing at a time, and that would be doing it well. Like if in a restaurant business, if I'm a chef, I know about how to cook things. If I am a waiter, I know how to take order or what recommendation to give to customers. If I'm a bartender, I would know what kind of drinks would be mixing well and what won't work for a particular person. So that's what I'm doing. I'm doing one thing well instead of a taco stand where that person is doing everything. We want any specific thing to be done by those individual, and that's why we say that microservices do one thing well at a time. Okay, what else? Other characteristic you will find that they are independent. Independent in the sense that they are not directly talking to each other. There would always be a layer in between, and that layer is ensuring that if there are some challenges with one tier, it would still keep on functioning without any issue. So that kind of independence is built into microservices. If you created a microservice and A is trying to talk to B at the same time, then it's not a good design, because if A fails, B would also fail. So we don't want that, and we want to make them as independent as possible. Okay, what else? Other things which you will find here useful will be that microservices will become a black box. Idea here is I just talk to that interface. Is it returning value based on Java function, or was it written into PHP, or they changed .NET at the backend? I don't care. For me, it is a black box. I have a microservice endpoint where I send my request and I get my response in a specific format. What they are doing at the backend, none of my business. Like when you go to a McDonald's drive-through, what you do first? You first order, right? Then you pay for it. And third thing you do is collect that particular order which you have placed. Who is working at the back end? Are they using microwave? Are they using a fryer which is running by solar heat? Or is it using a specific type of brand of the oil? It doesn't matter. So interface would remain same. Any McDonald drive-through I go through, I would have the same thing. I would first order. Second thing I would do is pay, and third thing I would do will be collect. And how they are managing the at the back end, I don't care. So everything for you remains a black box. So you provide some input and you expect some output in a specific format. That's how your black box services would be working. Another approach with microservices are is that you build it and you run it. Right? What we want to ensure that you are not just throwing away your code to development, sorry, your operation team to deploy. If you have built your application, you would ensure that you are also maintaining it. So you build it, you run it, you break it, you fix it. This also solves a problem of communication between development and operations team. So microservices are designed with a mentality that individual team would be talking about and would be maintaining those services, and they would be running these services also. So hopefully everyone is clear and got a little bit more idea on how all these things would be working. Is it recommended to have microservice being stateless as a characteristic? VK, I would say yes, probably. Otherwise, if you are creating a service in which A talks to B directly, then you are again just creating a bigger monolith. That's all. So most of the time, they would have a well-defined way, they would have a persistent layer, and they won't be talking to each other directly. There would be somewhere in between where the data would be persisted for communication. So most of the time, yes, they has to be designed in a stateless fashion, and then only you would be able to scale it. Otherwise, there will always be challenges. Right. So what you could do, let me try to give an example here. Let's say if you are trying to do things like that. Let's say this is your service A, and this service A wants to talk to B. Now, if you are sending data directly here, and if B is not available or A is not available, then your architecture is down. Instead of that, what you could have done, maybe added a caching layer in between. A doesn't talk directly, A send data to caching, and then B pulls data from this caching tier. So even if A is down, but if the caching layer has data, B can keep on functioning. If B is down, A can still keep on functioning because it can keep on adding data into caching layer. So that is a better way to do implement. And if it is stateless means we are not keeping any state information, then it is easy to scale it to more front end or more back end. So probably you would keep it stateless most of the cases, not always. So it, I would say, depends, but approach should be to not them talk to each of them directly. Otherwise, you are defying the purpose of building a microservice altogether. Okay, good. Now, let me give a simple example of how the interface works. What you are seeing here is set of wheels, right? Question, what do you see as a common thing in these wheels? Do you see anything common in these wheels which I'm showing? Obviously, all are made up of rubber and steel. That's fine. The tires are there. That's true. What else? What else? Yeah, tires. Shapes. A wheel should be circle, isn't it, Farna? It would be very complicated. Round and glossy. Tire size. Tire sizes can be different also. Wheel are circular, exactly. Shape is same. Yes, that's what I expected. Let me give a little more idea on that. Let me try to talk about what I'm looking for. If you are looking for fixing this wheel into an vehicle, how you fix that? So to fix that wheel, you need to see this section here, right? See this section here. See the section here. Do you see any similarities in between these? Anyone? Do you find out any similarities between what is this section? Right. Some of these folks may have Rocket League wheels. All of them have five. Exactly. That's what is happening. So what I'm seeing here, that if the place or the vehicle in which I want to fix this wheel, if it has the same interface, whether I go with a sports type wheel or whether I go with a traditional type wheel or with more spikes in that, it doesn't matter. It's the same interface which we are following, and that's exactly what microservices are allowing you to do. They are allowing you to have a standard set of approach. So in any vehicle, if you have this five center point which are same, that is your interface. So that interface is same. That would mean that we are able to attach any supported wheel inside. That's what an API is. That's what an interface is. So hopefully that gives you idea that interface is same, and that's why any wheel can be attached into this vehicle should not be a problem. Now I'm not saying that every vehicle would have five set of nuts and bolts, but I'm just giving an example here so that they would be able to fit in. And whether I replace wheel or not, it doesn't matter, because these wheels are having the same standard component, and that's how I could get connected. So that's what my meaning of is a interface is the same, and then you could build that application through Java or PHP or .NET. It doesn't matter at all, because you are talking to the same interface all the time. Everyone okay so far? Right? Good. Okay. Let's move forward and let's talk a little bit more on the serverless side now. Now, serverless is an approach. It's not mandatory that all the microservices has to be implemented using serverless architecture, but serverless is an approach, and we are going to talk a little bit more on how your serverless architecture works and why exactly we need serverless. What is the best use case of serverless architecture? And if the time permits, I would talk about two of the services or maybe three of the services. One is Lambda, another is API Gateway. And if time permits, I'll talk about step function also. But these are some of the serverless architectures or services which AWS has to offer. Let me give you an idea that why actually we need serverless architecture. Let's get started with that. Can anyone recognize what this photo is? Anyone? What is this here? What is I'm trying to show here on the picture? Anyone? Let me use that time to drink a little bit of water. Check-in service, check-in counter, exactly, airport check-in. Yes, that is a kiosk which you find on airports, and it would be a check-in kiosk in which you could go scan your scan your passport or maybe enter your PNR number, and it would print your boarding pass for you, or it would print your luggage tag, or it would print, or you could change your seating arrangement there, or you could order a food or something from that. So that is a kiosk. And is there a man behind it? Answer is no. It is a kiosk, so it is just working, and anyone can come in and can start using this service. There is no manpower required to be standing there always. This is a running machine. Nol card type Muhammad. I can relate it to Dubai. Like there is a Nol card which you use for your vehicle, and that's the exact same thing. Sorry, Nol card is that for your riding the metro or buses, right, Muhammad? So Knoll card is what you use when you are riding a bus or a train or a metro. That time you utilize that Knoll card. Yeah, metro, exactly. Okay. Now, most of these things, this will be running 24 by 7. But I don't expect that people would be lining up here. Somebody sometime would come and then they would be able to utilize this service. So this kiosk would be running 24 by 7, but it doesn't mean that my backend also would be running 24 by 7. Let's see. In current situation, if I'm keeping my front end running 24 by 7, the backend server also has to be running 24 by 7. And this backend server may be serving multiple kiosks. What this backend server is actually doing, the server is actually doing some processing. So when you enter your PNR number for that this kiosk like this one, what happens, it would check what kind of passenger you are, do you have fulfilled the requirement, what is your booking ID, show it to you, give you option to print your boarding pass, give you option to change your seat. So that backend is processing only when somebody requests something to be processed here, so only then it would run. But what is happening here, that this will be executing some code and I have to ensure that I am keeping it running for very long period, in the sense that it would be executing the same code for me, and I have to ensure that it is mostly idle. It is costing me money to keep it running 24 by 7, and it is having operational overhead also with that. So that is what commonly would be happening when I have a 24 by 7 running machine in my environment, right? Okay, let's think more on that. What about a service like a chatbot? Chatbots are becoming very common, right? You go to your bank site or you go to a company site, they would have a chatbot, and this chatbot will say, "Hey, how can I help you?" And based on the input you provide, it would do some processing for you. But if you look at a chatbot, it is basically sitting idle. It won't automatically become active unless and until somebody asks a question to that chatbot. And if I have a 24 by 7 server running for this chatbot, basically I'm wasting my resources in that case. So that is another example where I do not need continuous processing. All right. Now, when I say this example, people think that serverless is only good when I have to build something which is not doing continuous processing. I would say not always. Let me give you an example here from a website from NASA. This one is a project which NASA runs, which is their NASA Mars rover. So this is a web application they have built, and this web application allows you to send your name to Mars in a digital format. Let me try to open it into a browser and I'll show it to you from there. Give me a minute, I am opening it up. So this website which is there, which is called Send Your Name to Mars, this one is built on a completely serverless architecture. Through this website, what you could do, you could register your name and NASA would digitally send it to the Mars mission when they are sending data. So just to make awareness about people, so they give you a boarding pass like this. So you could go ahead, register yourself. It's an old approach now, but yes, you could go ahead and put your name, get your boarding pass, get your maps, frequent flyer information, and all the stuff. So that is just to make little more awareness about for people into the space program. Now, how this is working at the backend. At the backend, if you read this article, and I'll send you this link, this is running something called all the microservice based architecture. It is leveraging Amazon CloudFront. It is leveraging Amazon S3, Lambda at the edge for processing, API gateway as a dispatcher, and then at the backend we are using DynamoDB. So everything here is a microservice architecture. And when there was huge requests coming in, the site scaled to 67K requests at a given point in time. So you could realize that it's not only for very small workload, it could be the huge workload you want to handle, and it could still work from it, should not be a problem at all. So that's how our services can help even design any architecture at any scale. It depends on how you want to realize and use those particular services. Okay, everyone okay so far? Now, let me talk about some of the services we offer from AWS, which are serverless. Right. So serverless is a mechanism of delivering a service. It's not one specific service, but multiple services may have a serverless component associated with that. Let's see some of them here. Now, here we have compute. Compute is a way where I am looking to process something. So if I want to process something, I need processing power. Processing power is in terms of CPU. I would be needing RAM for it. I may need network connectivity for it. I may want to have some local storage for my data. So the service would offer that. Service which is Lambda, which will offer you the same component. Fargate is another service, but this one is purely focused on containers. So we could run containers from it. So this is what we can offer for serverless architecture. What else? Now, this is one component compute. What about if I need a front end for my application, a API handler? So we could deploy it through Amazon API gateway, again serverless. API proxy is basically being used here. That's what we can leverage. And when it comes to store data into databases, we still offer serverless option. So serverless is DynamoDB, Amazon Aurora. So serverless doesn't mean there is no server. When you execute Lambda, somewhere some server is still there. But only difference is that you are not maintaining that server. It is someone else's responsibility to maintain that server, keep it functioning, keep it running. And when you need it, the server would be given to you for a short period of time. You get your work done, and then server is pulled back so someone else can process data on that. So that is the main idea. Serverless doesn't mean there is no server at all. Only thing is you don't see those servers and you don't maintain it, so you can focus on building application rather than maintaining server and maintaining the workload on that. So that is the main idea of serverless. And serverless is a term which can be serverless compute, serverless API, serverless databases, and then there is a inter-process messaging. So inter-process messaging, when we have services to communicate with each other, you could use SNS, you could use SQS, and if you have to orchestrate multiple services together, then we have orchestration service like step function. And then if you are looking to store something, then obviously there is Amazon S3, which is again serverless. And if you are looking for analytics, there are services which work in serverless fashion like Kinesis, Amazon Athena. So they could all help you in getting your work done. So serverless is a common term. Multiple services may give you a serverless approach, and when you maintain or use serverless services, you basically save your time and efforts and do not worry about backend. So you could only focus on building the best application experience for your customers. So that's what is the idea of a serverless, right? Good thing from Crystal here that as an architect, think about how make your life easier to use serverless as underlying infra fully managed by it. So exactly, that's important stuff. So probably you should be using this. So make sure that you leverage serverless services so that you do not have to maintain it and let somebody else maintain it. They are good in that and we would utilize it. Is AWS Glue a serverless service? Yes, Makha, it is. Right, but there is one more component in that which can be used, which can give you something called in Glue. There is a component which we call endpoint. Endpoint is not serverless. There is a server which is running at the backend, right? So good thing, everyone. We are seeing a lot of comments. Thank you for that. So we will talk about Lambda functions, how Lambda functions work and when to utilize them, what is the advantage of it. But I think it's a good time to take a short break. And once we return from that, we would then talk about how to utilize Lambda function. So let's take 5 minute break and then I'll talk about Lambda and show you some demo so you could relate to. So enjoy your 5 minute break and I'll speak to you in 5 minutes. Thank you. Welcome back, everyone. I hope everyone is back. If you are back, type in chat who is your favorite superhero, right? Who is your favorite superhero? Let's see what people come up with. Iron Man, I like that. I like that. Flash, BeSA team, thank you so much. It's so humbling to hear that. Iron Man, my dad. Yeah, Logeshwaran, that's nice one. All Khans. Oh, similar analogy, Ashish. Oh, come on. Thor. Yes, exactly. I like people from Marvel Universe, and I like Captain America. He's like very dedicated, soldier spirit, very helpful. So yeah, that is what my favorite is. But yeah, obviously everyone has some favorite superheroes, and it should be right. Good, thank you. All right, so let's focus more on the Lambda. Let's make Lambda our superhero right now. Let's see how Lambda functions work and what exactly we are utilizing. William Butcher. Good. All right. Let's see that. How Lambda works. Now, for understanding Lambda, consider that Lambda has two components. One component is the Lambda service itself. So what I'm showing here is the whole gray box, which is having this AWS at the top. The whole gray box I am representing as a Lambda service. So what you interact with when you need to process something, you interact with a Lambda service. So Lambda service who would take care of all the backend information for you. So you interact to a service. And in that backend service, you write your code into something called a Lambda function. So what you see here at the top, that is your Lambda function. So function is where you write your code. It could be .NET, it could be PHP, it could be Java, anything which you feel comfortable with. That is what you would be writing your code in. So your code is stored into a function, and function get executed by the service itself. So be aware, service is this is my service, and here is what my function is. I write my own functions. Right. So let's see how this service actually works. Let's see how components would work. I am trying to explain you how AWS Lambda works. Okay, let's see this. Now, let's say a person comes in, he or she is trying to do something on your front end, and that front end has some Lambda function integration. It is integrated with Lambda service. So as soon as somebody is doing something on this kiosk, I would call that is basically an event happening. So what they are trying to do here, they are trying to do an event. And that event could be simple as scanning their passport. Event could be clicking on a button. Event could be receiving a camera input or camera detecting a motion or camera detecting something. It could be anything. Event is something which is a trigger point. So trigger could be a click, could be an API call, maybe did a fingerprint scan, whatever it is, that is called my trigger. Lambda is also called event-driven architecture or event-driven service. Event is something who would trigger a Lambda function. So that's what happens now. I did my passport scan and that Lambda service received it. When the service receives it, it would be getting some parameter from it. It will tell which Lambda function to execute because I may have Lambda 1, Lambda 2, Lambda 3, and so on. And I may want to always ensure that only legitimate requests are doing triggering on that. So this service here would send detail about which Lambda function to trigger and maybe some security whether we are allowed to trigger that Lambda function or not. So that is the first thing happens when a Lambda service is actually triggered. So event is triggered from front end, an API call, a fingerprint scan, etc., whatever it is. Second thing, AWS Lambda service receives the invocation call and trigger corresponding Lambda function. Whoever is the Lambda function, that's what we would be utilizing here. This is what my Lambda service is doing. So this is Lambda function. Here it is my code written, right? What else? Now, can anyone tell me if you have any code written, what component you need to execute this code? What we need to execute this particular piece of code. Let's say it is Java, PHP, .NET, a language of your choice. What are the components required to execute that particular code? Compilers, exactly, or runtime. So yes, we need that. Somebody who could understand this runtime compilers, you call it interpreters. So that is all we need for that. Exactly. Runtime environment. Yes, we need runtime for that. So that is always required. A runtime who would be doing the processing for me. Apart from that software component of runtime, I also need a CPU, right? Because actual processing will be done by my processing tier CPU. I would be needing some memory associated because CPU doesn't work well with hard disk. They need to access data from RAM. They may need to have some network connectivity. What if through this function I wanted to talk to DynamoDB and get some data from there? So I would need network connectivity and maybe some temporary storage. Maybe we got a zip file from somewhere, we uncompress it, and then we deliver result back. So these are the common thing we would be needing. Right, we would need a runtime and we would need a processing tier to process our code which we are utilizing. Right, what happens now? As soon as your Lambda function is triggered, it would have configuration setting, like it would tell about how much memory is required. That is the only parameter which you configure in terms of performance to your Lambda function. You just say how much memory you need and your CPU and network is allocated based on that. So based on how much CPU you need, how much network you need, that would be added into your function. You define only memory and CPU and network get allocated proportionately. So let's say my functions require 256 MB of RAM. Good. This requires code written into Java. Or let's say this is a Python code which I want to execute. What Lambda service will do now, it would check what my component requires, what my function requires, and it has some pre-configured servers running. They have Java runtime, they have .NET runtime, Python runtime, whatever common languages Lambda support, those servers runtime is already running, and it's not one server. There are hundreds of servers which has supported Java, .NET, Python running in that. So when your code has to be executed, what Lambda service would do at the backend, Lambda service would execute it on a suitable environment depending on the language, depending on the memory. What is actually happening at the backend here? At the backend, depending on what you requested, a small container is getting ready for you. You don't see it, but actually your code is pushed inside a container. The container would have required runtime, the container would have required memory, and your code get executed inside this particular container. And once your work is done, because this container can give you CPU, memory, runtime, disk, whatever you require, that information once processed may be given back to your front end. So once your processing is done, let's say we got output, you did a seed change in your flight, and that information may be sent back to the backend and said done, we have now our processing done. Right, so that's what a Lambda function is doing. So at the backend, for every Lambda execution, a container gets started, and that container will be executing your code. Once its work is done, we would be removing that container from your environment. And what is the advantage here? You do not maintain anything, you just say what you need, and we would be able to give you that required container and get your code executed. So that's how on a high level your Lambda function works. Now, getting result to the back end is optional, right? What do we mean by that? Sometime I may want to display to the front end, hey, your work is required, you is accepted, and we are working on it, right? Or sometimes we may not acknowledge anything on front end and start just doing the work. So it depends. So we'll discuss a little bit more on that. But this is how anatomy of a Lambda function is, how a Lambda function actually works. So advantages here: no servers to manage. Another thing is I get to pay for millisecond my code is running. I do not pay to keep services running for longer periods. So I'm just paying for millisecond. Automatic scaling. Now, this is one function, right? But what if we have 100 kiosks and all of these kiosks are looking to execute the same function? No problem at all. Lambda service can do concurrently scaling. So it could scale your environment. You don't have to create 1,000 functions. You create one function, and that function can be concurrently executed for multiple requests, completely independent. So that's how Lambda functions actually work. So no automatic, so no scaling required, automatically scans, and then it has a rich ecosystem. What I mean by that? By what I mean by this rich ecosystem is that it is not independent service. It can talk to other services also. Let's say it talks to CloudWatch for logging. It talks to X-Ray for its performance. It has integration with DynamoDB so it can get data from there. It can be triggered by your SQS service. I call Lambda as a Swiss Army knife. If you see Swiss Army knives, you would find that in one single knife, they would have a scissor, they may have a cutter, they may have a nail plicker, or maybe something else. So in one single Swiss Army knife, you can achieve multiple function. Same as with Lambda. Lambda can give you lots and lots of specific things. Can we choose a particular DB? No problem at all on that. It could be anything. See, basically you are writing a code, and if your code can talk to a specific database, or it can talk to S3, or it can talk to even on-premises services, it doesn't matter, because we are basically running a code execution engine for you, and whatever you could achieve by writing a code, Lambda can hopefully finish that for you. Should not be a problem. So that should not be an issue at all. Right. Okay, good. Cricket score match we watched on Hotstar 6 is example of Lambda. I'm not sure, Vishal, how it works. It should be a little different because it's a streaming which is happening the live stream. Maybe when they click something and say, I want to display the total score, or I want to display the average score, or from something else, maybe when processing is required, that time Lambda is accused. So for processing, you would be using Lambda. When you are watching match live, that time probably they are using some streaming services for sending videos to you, right? So it depends, I would say, how it works. Okay, so advantages are this, but there are some more things which you have to consider. So is Lambda going to solve all my problem? Answer is no. There are specific use cases where Lambda is a good choice, and there are some cases where it would not be a good choice. Let's talk about those cases. There are some limitations. That's what I were coming to now, VK Rao. We are talking about limitations now. First limitation is maximum 15-minute duration. The container which is started for you here is given to you maximum for 15 minutes. We would destroy that container into 15 minutes. We won't keep it running for longer than 15 minutes. We don't want anyone to monopolize the whole service. So that's why maximum execution time is 15 minutes. It's not beyond it. If your code is still executing, in 15 minutes, your container would be destroyed. Maximum duration of execution is 15 minutes. That is one limitation. Second limitation we give you maximum 10 GB of RAM. So it'd be sufficient, but if you require something very specific, let's say you are doing some machine learning, or you are doing some graphical analysis and you need more RAM, or you need specific type of CPU, it may not be available. So that is the maximum 10 GB RAM which is given to you. And then it is a stateless execution. The container which is given to you, it would have some local disk space on that. But as soon as your function finishes, once your code finishes, that container get destroyed. So if you stored something here, then it is not maintained for the next execution. And that's why we always say, if you are using Lambda as a service, and if you have to store some data, store it outside of the service. The outside could be S3, could be DynamoDB, could be a queue, could be anything which you could think of. But it is not keeping your data locally stored within service, because that container would be removed within 15 minutes of execution. Now, how determine the code should exit within 15 minutes? See, Vikirao, when you are writing a code, you would know how long it takes, right? So you would know, let's say I'm having an image processing. So if I have this image processing service, what I would know that if I have image size less than more than 5 MB, but less than 20 MB, maybe it takes 2 minutes to finish. If I have image size more than 20 MB, but less than 40 MB, maybe it takes 5 minutes. So you need to figure out that how much time your code may take. So you would need that information to use Lambda efficiently. Otherwise, you would be wasting money. I'll talk about that example. So it's stateless execution, and it may have a potential cold start. It can be bypassed, but potential cold start is you send request, Lambda was triggered. Lambda would go and figure out, hey, give me a container which has this much capacity, this much performance. So this service would create a container for you. So maybe it may have some millisecond latency for your first request because it is starting the container for you, and that's what we call cold start. In very first execution, it may take little more time to get started because it is starting the whole container thing for you. So that's how we could go ahead and utilize the service. So this is what anatomy of a Lambda function is, and the service which fires up a lot of containers for you, the service at the back end is called Firecracker. It's no secret. This is open source technology now. So Firecracker is the mechanism behind the scene who can power on thousands of containers to run this execution code. And good part, we give you 1 million Lambda function free per month. So you could use a lot of Lambda function, and if you below 1 million, then you still don't pay anything. So it's a really, really nice service to get started with. All right. Hopefully everyone is clear. Now, is Lambda going to solve all my problem? I would say probably not. So let me give you a simple example. Now I have accessed this site before. I'm not sure if it is still functioning or not. So give me a minute and I'll talk about that how this service is and what it can do for us. Give me a minute. I am powering on a browser and we would get started from there. So the service or the website I am going to is servers.lol. This is just a temporary way of checking the performance. Now it is invalid certificate, so don't put your personal data here. Don't put any complicated data here. I'm just using it to show some information to you. This basically says servers.lol, they are trying to say, should your EC2 be a Lambda function? So should you use EC2 machine or should you use a Lambda function? So let's see that. First question it is asking me, hey, let's figure out whether you are a good candidate for serverless or not. So let's say my code is written into Node.js, no problem. But if my code is written into, let's say, COBOL, then it says some of the language you are using are supported in Lambda via the use of Lambda layers and custom runtime. Means these languages like COBOL, or if I'm using, let's say, Rust, they are not by default supported. Can it still be run? Answer is yes, but you would require a little more careful planning for it. These are not natively supported, but you can bring those through something called Lambda layers. Right. So what I say, let's say my code is written into Node.js. Okay, done. Can your function finish within 15 minutes? Now this is important. We are talking about one function. Maybe my whole application takes more time, but I am focusing currently on one function only. So let me see if my function can finish within 15 minutes. I say yes, that's fine. Now I am modeling application. Let's randomly get a name for application. Let's say browse drive. That is my application. I'm expecting I would have 40 requests for this application, or let's say 5 requests for this application per minute. Just give me an example. My average duration to get this service sorted is, let's say, 400 or 40 milliseconds. My function requires, let's say, 512 MB of memory to function. So I'm just giving some information to my application called browse drive, and we will see what my pattern is. So let's say my application is having a pattern like this. I have low traffic, periodic activity, and currently I am running it onto m5.large, and I have 3 servers running to handle that workload. So this is one application which is having 5 requests per minute, 40 millisecond of average duration, 512 MB of RAM, and it has low traffic, and it is currently running on M5.large with 3 services running there. Good, that is one application. Let me add another application. Let's again generate random name for my application. Let's say Ibu. This one is busy. This gets 500 requests per minute. Average duration, it is doing a lot of processing. It requires 600 millisecond, and this machine requires, let's say, this much of RAM. This function requires this much of RAM, and this is a very active application. And to maintain it, I have 3 servers running. Right. Let's see the results now. So I have put information about 2 applications. One is very busy, require a lot of resources, doing a lot of processing. Another one which is not doing a lot of processing. Let's get result here. See this. If I start using my browse drive application, if I use EC2, I would pay around $207 for that workload. And that cost is in Lambda is just 0.22. So this is a good application to get started and use for Lambda, because this is how we would be saving a lot of money. See, where is $200 per month and where is 0.22? right? So that's how this one application browse drive is good candidate for Lambda execution. What about other application? One application which is ebu, this one is complicated because of its high performance and it's a lot of requirement to run again and again. I may not get any saving from it. If I use Lambda for this function, I would actually end up paying more in that case. So we need to estimate and understand that how much money may be involved to get this service running. It's not like every problem Lambda would be the best solution, but yes, not everything, but some part of your application may be well suited to run as a Lambda function. So it will depend on how you have designed your application and how you could utilize it. Right, good. Lambda can access any service inside AWS and external services. There are restrictions. I would say, Daniel, the question which you asked, the restriction is purely based on like what you are able to write in your code. That's all. So Lambda has no restriction. If you could achieve what you want in a code format, and if that code can be executed on a CPU and memory, then probably Lambda would be able to utilize it. Should not be a problem at all on that. Right. So that's how we are able to utilize. So that all depends on how you write your code. Can we get the bill per Lambda function? See, what you could do in this particular case, if you are looking for Ramkrishnan, you can put a tag on your Lambda function, and when the bill is generated, then you can filter based on that tag, and it will tell you how much we have executed for that Lambda and how much we are going for that. So you would need to associate tag and generate your billing report based on that tag so that you would get that information, right? So hopefully it is utilizing that. Question is, who is maintaining these servers? AWS. Who is maintaining servers.ll to give this cost estimate? I think it is a free website. I don't know who is maintaining it. I just found it useful and easy. We have tools in AWS to estimate the prices, but it requires a lot of input, and that's why I didn't use it. But I think this one is a free site. I don't know who maintains it. I found that useful resource, and that's why I just shared it. But who maintains, I have no idea on that. Okay, good. Okay, let's go ahead and talk about how actually it works. Can we have invoice based on function? Answer for that is no. Your invoices are based on your account. In that account, you could then create a report for your Lambda function. So when you get an invoice, it won't be separate for Lambda 1 or Lambda 2. Your whole AWS account would get a bill, and in that, you would get a cost of total Lambda service. And then you can drill it down that report by putting tags and then doing compiling or running some queries. But invoices are generated on an account level, not on individual Lambda function level. Okay, now let's see how Lambda actually execute. So first thing, when you have a Lambda function, that Lambda function can be triggered. We use a specific word which is called invoking the Lambda function. So we trigger the function. It could be manually triggered. It could be scheduled. I could put a schedule, and on that specific time it would work. I want to take backup every Wednesday on a specific day and a time. I could schedule it. Or a service can talk to a Lambda function and invoke it. So you could say, I will show some example in a minute, that I have a S3 bucket. And as soon as a file is uploaded into S3, it should go ahead and talk to my Lambda and execute it. So it would be how it would be executing. So it is basically requiring a trigger. Once a trigger is done with Lambda, what Lambda can do? Lambda may or would assume a role. Probably you understand the role, a mechanism to give permission to my Lambda. So I want this Lambda to talk to DynamoDB or S3 or some other services. I have to enable permission on that, and that is done by role. So that role would be assumed by Lambda function. I would associate a role, and through this credential, it would be able to talk to other services. I would just call it perform action. This perf action could be within AWS, could be outside, doesn't matter, because Lambda is basically executing the code for you, right? What else? When this whole thing is happening, what you could also do, you could get all the logs information into a CloudWatch logging service. Sorry. So you could get this information into your CloudWatch logging service. So you would be able to see what actually happened, when it happened, how much time it took, those kind of stuff. And I could get monitoring information in detailed format into another service which is called X-ray, but it is optional. It is not a mandatory thing. So if I'm troubleshooting, then probably this would be a good way to check how much time it is taking, how much tracing is it. So X-ray can be utilized. Otherwise, by default, all logs are collected into CloudWatch logs. So that's how your Lambda function actually execute. I have put a very high level estimate understanding here. There are lots of things happen behind the scene, but this is on a high level how Lambda functions actually execute. And if you want to play around, there are a lot of resources available where you can build a hello world Lambda function, serverless data processing. So let's quickly go to a Lambda function and let's build it. And then we will be basically seeing some advanced stuff associated. So let me log into my account and I'll quickly show you a single Lambda function, and I'll show you a whole application which could process Lambda and then perform some additional stuff. So we'll discuss that in a minute. Okay. Now, probably I may not get time for covering API gateway. I don't want to rush. So probably in some other time, we'll discuss about API gateway. Let me currently focus on Lambda function. So I'm signing into console and I would trigger Lambda function. We already have a lot of samples available. So you don't have to manually type code for everything. There are a lot of pre-built template or blueprint available which you could leverage. You are looking to get data from a stream. You are looking to get data from S3. So those templates are available. Lambda is a regional service. So I would select a region, which is, let's say right now, Ireland. And now I would start looking for my service, which is Lambda. So let me go to Lambda as a service. So be aware, for service and function are two different things. Service is the whole stuff. Function is what I create within that service. So now I am going to see my Lambda function and we'll see how it works. Okay, these are some Lambda functions which I already have. Let me go ahead and create a function here. Now I am showing you it from UI, but you could do it from command line. You could do it from API, from any other platform like .NET, PHP. They all support runtime for Lambda. Sorry, they support integration with Lambda. So maybe from your Visual Studio or from your PyCharm editor, you could directly create a Lambda function. So I have option here to author from scratch, use a blueprint. Blueprint is basically we give you some template to get started, 46 of them. Get started with HTTP, Kinesis processing, Kinesis analytics, node execution, microservice endpoint. So there is all Lambda. I may also run container images on that. So I could provide container image information and it could execute for me. Or I could browse a serverless app repository where we give you lots and lots of pre-ready to use services. As you see, Python, FFmpeg, Lambda layer. Then you have Alexa skill. Alexa completely works on Lambda. When you say Alexa do this or do that, basically a Lambda function is getting triggered, and that's how you are getting your stuff ready on that. So that's how your Lambda functions are. Let's keep it simple. Let's author from scratch a very simple function. I have to give a function name. So let's call it test Lambda. I have to select a runtime. Now, these are the latest supported runtime. Others are also there. But what if I have a COBOL code or I have a Fortran code to run? That is not by default there. And for that, we allow you to run custom runtime. So that is also possible. So this is a very extensible way to add support for other languages which are not natively supported by Lambda. So let's say my function is Node.js. I could select to get it executed on x86, which is Intel and AMD based processor, and then ARM64, which is Amazon's own Graviton processor. Obviously, this would be little cheaper in terms of cost. Then I could have a role. By default, it is creating a role for me. I could change it, and then some advanced setting where I want to do some code signing, some tagging, put it into VPC, some URL for function. So I'm not going through all this, and I'm just saying, hey, create a simple function for me. So I am going to create a function here. So if Lambda is down, Alexa will be down too. Probably, but there are multiple ways on that, Ollie. So probably there is multiple ways that maybe it has regional independence or we keep that separate. It is, I'm just saying that the execution for Alexa in that fashion, but not 100% sure if Alexa will be also down when Lambda is down. I'm saying mechanism at the back end of Alexa is Lambda, but not the same interface. It may be implemented a little differently. We have Lambda at edge also, so that may be behind it. it where we could have edge location serving your content and delivering and processing data from there. So we are here, we are on test Lambda. My Lambda function got created. What it has done for me, it has created a simple hello world Lambda function for me. Right. So this is my index.js file. This is the code written, and whatever additional code I want, I could put it here and get it executed. And obviously, I have to add trigger if I want. So I could say, hey, you would be executed based on what? Let's see. If you Alexa skill is called, API gateway gets a request, code commit happens, somebody commits a code, I want you to trigger. DynamoDB gets a stream, S3 gets upload. You have Kafka services, MQ services. So that could be a lot of triggers which we could connect to, right? So triggers are there. So trigger who would invoke Lambda? Lambda would execute and then it would talk to some destination, maybe S3, maybe DynamoDB, whatever service is. It would go ahead and talk to it. I'm keeping it simple, and this is my Lambda function. Now, in terms of configuration, only thing which I can configure in this performance is memory. See this. So only editable parameter in terms of getting extra memory is this, that I can start from 128 MB up to 10240, not beyond it. So I could go ahead and say, hey, I am looking for 256 MB of memory here. So I could go ahead and change it. No issues on that. How much storage you could get? This is ephemeral storage, temporary, that is up to 512 MB minimum to 100240, but it would be removed back. And if you want any existing role to use on that, you could utilize it. Otherwise, this role has been created for me, and I'm happy with these changes. I made this Lambda function now consume 256 MB of RAM. Okay, let's go ahead and execute it. For executing, I am doing a test here. So I could create a test event. Let's call it just my test Lambda event. Now, this Lambda may be given some payload. Payload is, let's say this Lambda is an image processing Lambda, and it requires file name from S3. So that is called payload. Maybe this Lambda would be doing a photo scanning, and that photo input will be the payload for it. So I could go ahead and put some payload here, which is into format of JSON. If I want, fine. Otherwise, I could go ahead and say, okay, done. And let me test this Lambda. What happened now? A Lambda function was executed. It has given this result to me. It has printed hello from Lambda, which I have written into the code, and see what happened. It took little initialization duration of 135.77 millisecond. Duration was calculated as 2.17. 3 millisecond was the build duration. So we round it off into the nearest millisecond. So 2.17 was actually, and then we have build you only for 3. The initial duration is what I was calling a cold start. So when first time a container is getting ready for you, it may take little time. So this is the information which I got. Though I assigned 256 MB, the memory which I actually used is 56 MB only. And this is the information which I have noted, that what was my request ID. Every time an execution happens, we get a request ID. So you could track it if you want to. And in this, I can get information like what is my build duration, memory, and all the stuff. And if I want, I could further test it again. So let's test it again. Let's test it again. Let's test it again. Do you seeing the difference here? See this? My billing is changing a little bit. I have captured the previous information. Let me bring that notepad to you here. So this was the very first execution. This is the second execution. Do you see this? Now memory is same almost. This is the one, and see this build duration is 2. Now this time it didn't take any duration because the container was there already for me. So the container initialization didn't require, and if I use this container within 15 minutes, probably I won't be needing the init duration again. So this is what we mean by the cold start of the Lambda function. So this is a very simple Lambda function which I have done. I have made it a little more complicated by deploying a project, and I will send you the link. Let me show that Lambda function to you, that what else can be achieved from it. I am doing processing of images. So AWS has a service called recognition, and this recognition service can detect the photos you have. So I have deployed this function, and to run this function, I have configured it in a way that it would be triggered if somebody is uploading a file into S3. So let me go ahead into S3 and upload a object, which will be an image. This Lambda would pick up that file information, process it, and then store the metadata information into a DynamoDB table. So that is the architecture. I have image processing happening through Lambda function here. How Lambda would be triggered? Based on the input of S3. S3, as soon as gets a object, it would trigger Lambda, and then Lambda would identify that picture and see what is present inside through recognition service, which is another service I am leveraging in this particular case. Okay. And this is a very cool demo you could build on your own. I'll send you some links, so you should be able to play around with that. Let me search for a specific bucket here. I'm looking for this OCR bucket. This is my bucket, and let me show that how integration from S3 is very easy. Let's go to this bucket, and in this bucket I have option for something called event. So in that event I said anytime a put event happens, somebody uploads the object, completes the object, copies the object, these are all called my put event. So see this event notification, all object create event, you should do what? Go ahead and trigger this Lambda function. So this Lambda would be triggered, which would detect text into images. So if I push some images into this S3 bucket, it would go ahead and actually verify that image through recognition and add that data into DynamoDB table. Let me go ahead and upload some images here so that I could show it into DynamoDB in a minute. So I would be adding some files. Give it a few seconds to get ready. See this. So I have some pictures here. I'm utilizing this picture, green car, and I'm utilizing this bank card information, and I'm uploading these two images. Lambda would be getting invoked because of that, and it would then store its information into DynamoDB. So I did upload. Now what I'm doing here is a asynchronous invocation of Lambda. My S3 will send data to Lambda, and Lambda would execute. S3 upload won't wait for Lambda to finish processing. So we finished the upload, and that same time Lambda got triggered, but my upload was not waiting for Lambda to finish. That is called asynchronous communication. I am doing my stuff. I do not wait for others to complete that. So that's what I did, and my upload was done successful. And let's see if my Lambda was executed based on that. So if I go to this Lambda function now, I could go ahead and check its log, and in the log I would get all the information, so I could go ahead and monitor it. I have option to do a log analysis on that, and this basically is doing what? It would read image from that and store that information into a DynamoDB table. So let it load. Here we should see the code associated with it. Right. And when it executed, I was able to see that through X-ray, or I could see that information into CloudWatch logs. I should be able to get whole data here. So good monitoring integration is there. What I want to show you that output, those images I have added, it had a image of credit card and it has an image of a car. Recognition service should have identified the text in the image and have stored that into a DynamoDB table. So I configured that, hey, DynamoDB, let's see what options are available in that. Question from Parna, what if a non-image file is uploaded, will the logic will trigger or not? So yes, it would still trigger. But your logic can check if it is a non-image. So we first verify through logic, is it a valid image or not? And if it is not, then we can say, hey, let's stop processing and say it is not a valid image. So that is up to you. That is depends on what logic you want to write in your code, because Lambda is just triggered. That would depend on your logic. So this is my DynamoDB table. I have these tables here. Probably I have two tables. I have this OCR table where my results are being stored. So let me go ahead and I should be seeing some items inside this table. So I'm exploring the table item. And we'll see what it is able to detect inside. So I did a query here, run, scan everything, and see this. This is a file name which I uploaded greencar.jpg, I have uploaded a file called card.jpg, and in that it has able to detect some text. See this. This text which was detected was J389NLT. What is this text? This text is basically the number of that car's number plate. So you could have this. Let me quickly bring that to you so that you can relate to what I'm saying here. Give me a minute. I'll bring that picture to you so that you can identify what is inside that picture. And this is my green card.jpg, which I am bringing it here. In a minute, it should be there. So what you see here is your green car. If you see the number plate J389NLT, and if you see my Lambda was able to detect it, not Lambda, actually Lambda triggered another service called recognition, and it detected this particular text inside it. So that's information. This was my credit card information here, card.jpg, and what was in the card.jpg, let me show that too. It detected the bank name and it detected the credit card number from that image. So see this. So you could build as much logic as you want, should not be a problem, and you could get it executed through Lambda function. So hopefully this is clear, and I would now stop. I would be sending you this information. So there are a lot of tutorials you could go through. You could go ahead and implement this simple example which I have given you. It is available on GitHub. You could get started and implement it, and then some additional links which I will be giving you so that you could get a better idea on that. Right. Now, I do not have time to discuss API gateway. Maybe we'll discuss it some other time, but I'll keep that into the PDF. So in case you want, you can check it. So hopefully everyone was able to get this thing. Right. Now I would hand it over to James so that James can talk about microservices, the hard part, because it looks good, but yes, it's not that easy to get started. We need to take care of some components. So I'm adding James and over to you. Okay. Thank you. James, are you on mute?
There we are. You'd think after
Yeah,
doing this
good.
for 8 weeks now, I'd be used to unmuting myself, but obviously not.
All right.
Awesome stuff as always,
Thank
Ashish.
you.
Thank you. Hello, everyone. Yes, it's me again to talk to you for the third week in a row now. So maybe after this week, you'll be fed up of hearing me talk. So I spent a little while this week thinking about what I wanted to talk to you about because serverless and microservices are one of my favorite topics, but they're really hard. So I thought I'd take a slightly different approach and actually talk through how hard microservices can be and some of my actual experience getting it really badly wrong building microservices. And I actually want to start talking about monoliths again because these are kind of words I never thought I'd say a few years ago, but monoliths aren't all bad. Ashish talked about it a little bit earlier, but if you're building a brand new application, or maybe you're building an application for a small team, maybe it's an internal application that only a few people are going to use, monoliths are really great ways to get started. They're simple, they're easy to write, they're easy to debug. They're a great place to start because if you start building microservices straight away, then you need to deal with all of the complexity that come with microservices that I'll get onto in a little while. And if you spend all your time dealing with that complexity up front before you even know that the application you're building is going to work or it's going to meet the needs of the customers that you're building it for, then it may not be a practical use of time. And something I always think when I start a project is the KISS principle, which stands for keep it simple, stupid. And that's something to keep in mind, especially when you're starting out. Simple can be good, and make sure that the idea works for your customers first. And I say that because microservices are really, really hard. Microservices introduce a lot of problems into your application that you might not even think about. So when you think about complexity in your architecture or in your application, there's normally two types of complexity. You've got essential complexity and you've got accidental complexity. So essential complexity is the problem that your application is actually trying to solve. That's the stuff that you can't get rid of. You know, you're trying to build some software to solve a hard problem. You can't get rid of that. The other complexity is accidental complexity, and that's the complexity that you bring into your design by how you choose to design it. So if you choose to build a microservices architecture, then you're bringing in a lot of accidental complexity. You're adding a lot of additional things that you need to think about, as well as the essential complexity, which is the really hard problem that you're trying to solve for your customers. So starting with something simple and making sure that you're solving that essential complexity first is a great place to start. So what are some of the complexities with microservices? Whenever I talk about microservices and the problems, I always like to refer to the fallacies of distributed computing. So there are some fallacies that were proposed by somebody called Peter Dush and some of his colleagues at Sun Microsystems quite a few years ago now. And they talk about some assumptions that people make when they start building distributed applications or microservices. And the 5 that I've highlighted in bold there are the most important ones, at least in my mind. And they're all the ones that are based around networks. Because when you start to build microservices and break things out into smaller and smaller services, then you're introducing network. And as anyone who's worked in IT or even, you know, been in the world where your Wi-Fi goes offline, once the network goes offline, and the network does often, then things can't talk to each other. So the network introduces a lot of complexity into your application, and microservices make the network a fundamental part of your application. So let's think about this in like real terms now. So imagine we built a monolith, and our monolith has got 3 different parts within it. But this whole application is running in a single process, let's say for argument's sake, on a single EC2 instance. And there's some parts of our application that need to talk to each other internally. So we've got module 1 talks to module bit 2, talks to module 3. And I realize I've got A, B, and B there, and that should definitely be A, B, and C in green. Now, if there was a problem with module C, for example, because this is all running in a single process, well, then module B would also know about that failure. And then module A would also know about that failure. And then we could then quite easily either send that error back to the person who made the request initially. Let's say it's a user interacting with our system, but everything's really controlled. It's all in a single process, and we can much more easily handle these errors. And the things that can cause these errors are relatively small. You know, the server could go offline. We could introduce a bug in our code, but there's very few things that can really go wrong in that situation. Now, if we take this to microservices, so let's say we've got 2 services now. And what I want to do is just step through pretty quickly all the things that could go wrong in 2 microservices talking to each other. So the first one is that service A could simply fail. It could just not send the request. The second one is that service A could send the request, but then the network fails after the request has left service A. Maybe service B isn't even there. Maybe it's gone offline. It's not there at all. Maybe service B gets the request, but then fails to process it for some reason. Maybe service B tries to respond, but there's no network connection out of service B now. Maybe on the way back, the network fails again while the request's on the way back. And then maybe it goes to get back, but then service A has gone offline. Now, everything that comes after the request has left service A, so from number 2 onwards, service A has no way to know what has gone wrong. How long does it wait? Does it wait for 30 seconds? Does it retry if things go wrong? If service A does retry, but then service B has actually received the request, does service B process it again? Or how do we handle that? How do we make sure that service B doesn't process the same request twice? What if service B handles both requests after the retry and then sends both responses back to service A? Then how do we handle that? Does service A then process both responses? These are the challenges that start to come in when you move things over a network. Whereas if this was a monolith in a single process, this is a lot easier to handle because you've not got these same things bouncing around. And this is before we've even wrote any code. We've not even wrote any application code yet. And these are things that could still start to go wrong. So let's now get past the network and get to an actual business problem. So this might be a typical microservice architecture for an e-commerce website. And I've worked on something pretty similar to this in the past. So after an order is placed, then the payment needs to be taken, the order needs to be fulfilled, and then we need to raise an invoice. And you've probably seen this if you've bought something on Amazon. You know, you place your order and then you'll get a notification saying your order's completed, maybe a few seconds later. A little bit later, you'll get the email saying your order's been dispatched. And then once your order's been delivered, you'll get another response to say that your order's been delivered. Now, let's imagine the payment gets taken, but then the fulfillment service tries to dispatch the order and there's not actually any stock. Because this is, if you think back to the database session where we talked about transactions, if this was a single monolith, we could do all of that in a single transaction. Because this is now over separate services, we don't have them transactional guarantees. So when we place the order, we might have had stock, but by the time the order comes to be dispatched, the stock might have gone. So then what do we do about the payment? How do we roll the payment back? Do we just refund people's money? Do we hold and wait for stock to come in? Like these are business problems that we now need to solve when we introduce. So we might introduce a feature to reserve the stock, then take the payment, and then fulfill the order. But if we do that, then everything starts to get really tightly coupled together, and we're just like a monolith again. So as we start to develop features over time, we might actually add some additional features to this as well. So maybe our invoice service needs to start talking back to our order service. Maybe the invoice service needs to start sending data to the forecasting service and the payment service. And then maybe the fulfillment service needs to start talking to the payment service. And now what we've got is the worst case scenario, which is we've got a monolith that's distributed over a network because everything's really tightly coupled together. If one component of this goes offline, then we have a problem. And Ashish kind of talked about this earlier. You know, we want to prevent services talking to each other as much as possible directly to try and prevent this. So what can we do to prevent some of these problems? How can we get around some of these issues when it comes to microservices? And Ashish has already talked about some of this, but decoupling and independence are two of the most important things to think about when it comes to building microservices. Keeping direct interaction between two services to a minimum is really important. And if you do have to communicate between two services directly, then do that over really clearly defined interfaces. Embrace asynchronous communication. There's a pattern called event-driven architecture, which I'm hoping to talk about at some point in a later session, but that's a really good pattern for removing this communication directly. If you think about the pizza restaurant that Ashish talked about, that's all event-driven. So the person who sits you down will tell the server that you're here and then we'll walk off. Then the server will take your order, take that to the kitchen, and we'll put a new order into the kitchen and then walk off. So there's no direct coupling. Everything is happening through events. And you can do that in your applications, maybe by using some kind of event bus. So all of your services here are just sending information to a centralized place, an event bus. So the order service might say, I've got a new order created. And then the forecasting service, the payment service, and the fulfillment service may all be listening for that event, and they'll do some work internally, and then they'll publish that event back out there, and maybe something else will start to do some work. You can also start to introduce a queue, which is what I've got just in the line out to the fulfillment service there. So let's say the order service publishes an event saying order created. Instead of going direct, instead of the fulfillment service listening to that directly, we may put that event onto a queue. So that event is then sat on a queue waiting to be processed. So if we go back to the same issue in our last example and the fulfillment service goes offline, well, that means that everything else can still keep working. And the orders that need to be fulfilled will just keep building up in the queue and building up in the queue. And then once we fix our issue with the fulfillment service, whatever that may be, then we can just keep processing from where we left off because all the items are just in a queue. But nothing else needs to worry about that. The payment service can keep working. The invoice service can keep working. We can still keep taking orders. Everything is completely decoupled and there's no direct communication between things. The other thing that's really important when it comes to microservices is how you structure your teams. And this what I've got on screen at the minute is called Conway's Law. And it was proposed by a programmer called Melvin Conway back in 1967. And it's organizations design systems that mirror their own communication structure. So if you have maybe you're developing an application and all of your teams need to meet every week to discuss changes, everyone's constantly talking to each other, and you always need to agree on things before you release them, then you're probably going to end up building a monolith. And if you're aiming for a microservices architecture, then you may end up building a distributed monolith, which is the worst of both worlds. This can even happen if you're a single developer working on a project. I know this because I've been there, I've done this. I was working on a project and I decided I wanted to build microservices, but it was only me working on it. And what I ended up then doing was building microservices that all talk to each other directly. And then it was a monolith. It was really hard to manage, really hard to work with, really hard to debug microservice architecture. When really, because there was only me working on the project, I probably should have gone for a monolith. You can use this to your advantage though, because if you decide that a microservices approach is the right way, then if you set your teams up to be completely independent, allowed to make decisions on their own, allowed to choose their own tech stack, allowed to run their own applications, and then your teams only talk to each other to agree on the methods of communication, then you will likely build a microservices architecture. So you can use that as a strategy. You can set your teams up in a way to help prevent the problems that come with microservices and keep things really decoupled. So I couldn't go through this without talking about an actual architecture. So this is a microservices serverless architecture that I actually built as a proof of concept for a conference talk I gave a couple of months ago. And it's a completely serverless architecture that is a review service. So if you imagine you go on Amazon, you've bought something and you submit a review, what this application will do is it will take in that review, it will translate it if it's not in English, it will detect if it's a positive review or a negative review, and then it will, if it's a negative review, raise that to a customer service agent to then follow up on the review. And this is all completely serverless. There's not a single Lambda function. So this is all using serverless services that talk directly to each other. There's a link to the code there on GitHub. If you want to go and deploy that into your own account, you can. And I'll just quickly walk through what this does. So the first thing we've got is an API using API Gateway. And what the API does is that receives the review information in. It stores it in DynamoDB straight away. And then it just publishes an event to a central event bus saying there's been a new review. That's all that service does. That's just the front door of our application. It takes in requests, it stores them, and it publishes an event. We've then got our actual workflow that does the analysis and the translation, and this uses step functions. So it listens for the new review event, and it first detects if the review is already in English. If it is already in English, it will go straight on and detect if it's a positive or negative review. If it isn't in English, it will then translate it to English from whatever language it is in currently, and then go on and do the analysis of the if it's a positive or a negative review. And one of the really cool things about step functions is that step functions integrates directly with almost every AWS service. So you can do all of this without a Lambda function. Once the review has been analyzed, we then send a notification back to the person who created the review saying either thank you for your review, or if it was a negative review, we're really sorry you've had a bad experience. A customer service representative will be in touch shortly. If it's a negative review, then we put it into a customer contact service, which then just simply takes that negative review in, stores it into a queue, and it waits for a customer service agent to go and action that item. Again, this is all completely, these services don't talk to each other directly at all. This is all event-driven, this is all serverless, and there's no Lambdas. And the final thing I've got is this event history service. And this service is just listening to all events that are happening, and it's storing them in a ledger, if you will. So when it comes to debugging, you can actually go and look at all the events for a given request and see what happened in order. And that's a really nice way to help debugging. So yeah, if you want to have a look at that, the code's on GitHub. When you get these slides, you can go and have a look at that and maybe deploy it into your own account. So what I want to just close with is to say, don't be a sheep. And I say that because if you look at architectures, if you start to Google it, you'll inevitably see all the benefits of microservices. Netflix are doing it, Amazon are doing it, Google are doing it. So then maybe I should do it as well. And companies like your Netflix and your Google and your Amazon, they're scaling to millions of users and thousands of developers, engineers, architects. And that's why they need microservices, because they're working at such large scale. If you are building a brand new application or an internal application that's maybe got a handful of people using it, then you're introducing that accidental complexity for no reason. And I can say this because I've been there, I've done this. I was working on a project, it was a monolith. I moved it to microservices and then to serverless microservices. And then it actually became a lot more challenging. And the application itself was only really being used by a couple of hundred people, maybe. So at the time, I just followed the new shiny technology to go and work with microservices, when actually I probably should have stayed with a monolith. Remember, KISS, keep it simple, stupid. If I've put these links in at the end, if you are really interested in microservices and learning more, these are two fantastic books about microservices by somebody called Sam Newman. They're both on my bookshelf behind me. You probably can't see them with the camera. But one is about building microservices and patterns for building microservices. And the second is patterns you can use to evolve your monolith into microservices. So yeah, if you're interested in reading more or learning more about microservices and the architectures, these are two great places to start. So that's all. I will stop waffling on now. And I believe now Prasad is going to come on and talk to you about the question he asked in LinkedIn.
That was interesting. I like that option, like don't be a sheep. That's so relevant, James. Exactly.
I've done it before.
Exactly.
So I find myself like a
Exactly.
magpie sometimes. I think a lot of people do, where you see this shiny thing that everybody's doing and you think, I need to go and do that as well. But
Yeah,
keeping it simple
that
is
doesn't make sense.
no.
Completely true. Thank you, James. It was interesting. And now I hand it over to Prasad, and Prasad would talk us about the question related to databases. So over to you, Prasad. You want to share something or you just want to talk around?
And now I'm going to just share my thoughts. No, nothing to share.
Good.
Okay. So, yeah, interesting session. Like even one of my favorite topics, microservices and serverless. And I really liked James' example about the architecture that he has built. You can do that, like yourself. Think about any fictional scenario and start building something. Have your code base on GitHub if you are, like a programmer. If not, then like you can think about even the architectures, right? That will really help you to show your experience in cloud, even if you are not, like not getting chance in your current company. That really helps. But anyways, switching gears away from microservices and serverless and moving to databases. So the question that like we discussed about a couple of weeks ago, and thank you to everyone who has responded on LinkedIn, sharing their thoughts on how they would be answering. And the question was, like, you are a solutions architect and a startup has come to you to like ask your guidance on what uh, database they should be choosing, right? So what will be your advice? And all the answers that everyone provided are great. Like no, like it's like obviously you will not be telling them upfront that use a specific database. You will try and understand the requirements. You will ask a lot of questions, and all the questions were really good. Let me try and give like I'm not going to cover that because like on the LinkedIn group almost every kind of question was already covered, right? So let me try and put a different flavor here of what solutions architects do. One of the like if you ask me what makes a good solutions architect, is that our hearing ability. There have been meetings in which when I enter into the room, within first 5 minutes I know what the solution is, but I'm going to keep listen, and I'm going to keep asking questions to understand like what the exact requirements are before I jump into the solutions. We do not jump into the solutions or the services that are going to solve the problem straight away. We take that step back, try and understand, see the full holistic view, and come back. So to answer that question, like it'll be if you're in an interview and someone asks you that question, like something like that. Before recommending a database, I would try and understand their use case. I will have to ask a lot of questions to them to understand what their requirements are. So first thing, what I'll be doing is that I'm going to set up a workshop, a kind of a discovery session with the customer to understand their business requirements and the applications that they are planning to build. Like gone are the days when we used to suggest relational databases like SQL Server, Oracle, or MySQL for all the database needs of a customer. Today, we are in an era where purpose-built databases exist to support what application is specifically designed for. And in all probability, the modern applications that we build these days, require more than one databases. We talk about breaking a monolith to microservices, and each microservices can have a different database. What it means is that every component of your applications can use different databases. And if we take a, and this is where your chance of showing your consulting skills is, instead of jumping to a solution, always give them an example. Like for example, if you think about a e-commerce application, your order processing, which might be having the payments involved. So there will be a transactional element to it. So you might want to still use relational databases so that you have the strong consistency. But let's say if you have product details that you need to store, for that you might want to use a NoSQL database or like MongoDB, where you can show, save all the documents. You might also want to use some database for caching, like Redis database. You might want to do some clickstream analysis so that you can provide recommendations to the users who are shopping on the e-commerce. For that, you might want to save your data on a database like HBase or probably something like that, so that you can run some analytics on it. For your application, you might want to, do the logging and monitoring of how your application is performing, and you might want to use something like uh, Elastic Cache, Elastic Service Database. So your application have multiple components. Each component might be having different requirement of database, and we have the flexibility to choose those databases, right? So, but getting into more specifics, like there are ways through which you can map these requirements into a specific features of a database that you might want to use. Something like acid and versus base, that will help you choose, help recommend the customer or choose whether you would like to go for a SQL database or a NoSQL database. And even for a NoSQL database, we have something called CAP theorem, which will help you choose which specific NoSQL databases are there. And there are multiple NoSQL databases like key value database pairs, document-based databases, white column databases, ledger databases, graph databases, timestream databases. It all depends upon what the application requirements are, and based on which you might want to uh, suggest the kind of database. I can dive deep more into CAP theorem or acid versus base, and it allows us to choose right databases. Give it a pause here, like when you're answering a question in an interview, give a pause in between, and if the interviewer is interested in, yes, if you can explain me more about CAP theorem, then start diving deep into it, right? Like in the distributed, we have multiple nodes and the data is replicated across multiple nodes. CAP theorem helps in deciding what it does, and talk about consistency, availability, partition, uh, tolerance, and then start about, the Venn diagram that we have, the common points that we have, like out of these three, only two of them can be possible for a specific database. If we talk about a CA database, which is a consistency and availability database, what will be their features? Dive, leave that room for the interviewer to ask that follow-up question, that okay, explain me more about acid versus base or CAP theorem, and then start diving deep. And if an interviewer asks that question, then don't shy away from diving deep. Go as deep as possible. Acid versus database, don't leave it high level. If they ask a common question, if in the initial question, keep it very high level. But if they ask, okay, tell me about acid versus base, then dive deep, to the level that you can. talk about like atomic, consistency, isolation, durable, or a basically available, soft state, eventual consistency. Go deep into strong consistency versus eventual consistency, that how data is replicated across multiple nodes, like, and in case if you want strong uh, consistency, there will be a latency, but in case of eventual consistency, there will be no latency, but the data that you might get might not be the most accurate one, so eventually it will be consistent. So go into that, and then you can start talking more about the specific databases. Till now, the answer that I have spoken about, I have not talked about any specific database, right? I have not talked about whether DynamoDB or like, or any specific AWS specific service. We come into the exact solutions later on. And if you have a personal experience, then share that. Like in a questions like this, I always try and find in my past experience, that is there a way that I can bring my past experience, how I helped a customer choose the right database, or how I have chosen a right database. Or even if there is a failure story, like here in this scenario, before coming into AWS, I did not have a experience of working a lot with NoSQL databases, but have had pain of using the SQL databases. So generally what I do is that then I relate my experience with that. That one thing that we generally joke about is that choose database for an application as it if your life depends upon it. And this actually comes from a personal experience. I was working for a financial client in which we were doing transactional reporting, and we were using SQL Server as a backend database, because during those days, for every application we used to use a SQL Server databases. What happened was, initially it was great, but when we started implementing it for our clients and we started scaling it, uh, the performance of SQL Server degraded to an extent that we had to think about scaling it. And scaling relational databases is really hard. I'm not sure if you have ever had an experience of scaling SQL servers, but initially it will be like a vertical scaling, add more CPU RAM, but then it will be about, like at one point vendor would say that we cannot provide a more bigger database, or a box. In that case, you will have to go for sharding, and then it will be more difficult. It's very complex, it's very painful. It would have been better if we could have used some other databases for that. It was all about real-time reporting. And in the real-time reporting, when we had to save that data into a database, we could have used some other database, like a key value pair database or a white column database, instead of having a strong consistent database like SQL Server. That would have ensured that the whole latency of starting the transaction till the reporting is quite fast. And in case if there are any like queries that we had to run on that, then in the backend we could have streamed that data into a relational database and done those like queries on that for the reporting purposes. So now when I go into a specific like customer requirement, then I see that where all I can use databases that will ensure that it's not going to go into bottlenecks when the application is trying to scale. Yeah, those are kinds of the points that I would touch upon for a question like that, which is open-ended, which shows not only my technical knowledge but also the consulting skills. And I can talk about this a lot, like how to answer a technical question to showcase your consulting skills, but probably a topic for another day. But yeah, I see that we are 5 minutes over time today, so that's pretty much. Hopefully that was helpful. Any questions? Please do feel free to like yeah, ask it on the chat here or on the LinkedIn group. Yeah, more than happy to help out.
I agree on that. Means that this is not like a one black and white question which you say, hey, go for X or Y. You have to give a lot of thought process before you arrive to it. Now, thanks Prasad for that, and thanks James for this. We're getting a lot of questions about stage two. So we will run stage two in the similar fashion like this. So we'll have session 9 to 11 UK time next moving forward, and give us some ideas if you want. Like if you want to cover some specific things inside, we will focus on technical skills or behavioral skills. We covered a lot of technical skills in these 8 weeks, but next 4 week we want to plan our own behavioral. We always have agenda of our own, which we want will be, which we think will be useful for you. But if you have any other thing which you can think of which would help broader audience, feel free, and we would be happy to add those into our agenda. So hopefully everyone had enjoyed. Let us know your feedback. Let us know your suggestions into LinkedIn group, or reach out directly, and we would be happy to accommodate if we can. And if it is for everyone's benefit, obviously we'll try to accommodate it. Right. We are also looking for some other people to join and talk, like hiring managers and maybe recruiters, like how they recruit. But we don't want to make it only a recruitment drive, and that's why we would include a lot of behavioral things too. So please send feedbacks, and we would be happy to accommodate that. Okay. Anything else anyone wants to add? Crystal, James, Prasad.
Yeah, yeah, we changed the course of stage 2, as Ashish mentioned, that we you will start, we'll keep it as we have been doing, the technical sessions for, the wider community. So we'll be discussing a lot more behavioral aspects in the coming 4 weeks. Having said that, in case if you have any interview scheduled with any of the FANG companies, like Ashish is currently working with one of the person who has interview scheduled with Amazon and helping him with, like how to prepare for the interviews. I'm working with one of the person within the BeSA group who is going through another FANG company. So in case if you have guys any interview scheduled, or if you would like to apply for any of the roles, feel free to reach out to any of us. We'll be happy to refer you. And then if we have a specific target to work for, then we work 101 with the candidates to help them across that.
Good. Yeah, that is the idea. And we want to help as much as we can, and obviously you can help us in reaching to more people. So spread the word. Make sure you put BESA program as your hashtag when you're sharing something on LinkedIn. Send your YouTube links, or maybe just like the videos on YouTube. So at least it will give a YouTube algorithm and will display video to more people. So do your best to help us in reaching out to more people. And we are obviously trying our best to scale it. We are not able to respond to every message, but we are trying to respond most of them. And if we just forgot to respond to your message, give us another nudge, and we would be helping again if possible, right? So we'll meet again next week, and we would discuss more interesting stuff. We will think there was some comment like, can you keep some technical session at least for an hour? We'll see. We will see. We want to focus on behavioral part also, but we will figure out. And if you have any specific technical questions, send us, and we would be happy to answer that. Thank you, everyone. Have a good one, and see you next week. Take care. Bye.
Thank you, everyone.
Bye bye.